Hello, my name is Michael Hannon, and I will be doing the Physical and Chemical Properties and Changes Lab. And I've already read the instructions and the background information, and we will be doing the procedures now. So first it says, obtain 250 milliliters of deionized water. So we got a bottle of deionized water. I had to order this, couldn't find it in stores. It says place this distilled water inside of a small pot. So I got my small pot right here. And we're gonna be using this graduated cylinder to pour our 250 milliliters of this into the small pot. So let's do that. This reads up to 50 milliliters at the top, so that'll be a good indicator of how many times I need to pour it to get to the exact 250 milliliters. Ooh, got that perfect. So it says, it's hard to tell, but here's a 50 right there. So we're gonna be pouring that into our small pot. So that's 50 milliliters right there. Let's pour it again. Pour too much again. Tony, go, go, go. Got that perfect again. We got 50 milliliters, so we're at 100 milliliters. So we're gonna need to do this 3 more times to get our 250 milliliter mark. Am I short? Ooh, I was close that time. There we go. So we're at 150 milliliters. Too much. And closer. There we go. So we're at 200 milliliters. We have the last 50. Very good. Too much. And that's perfect. So we have our 250 milliliters of deionized water in our pot. We're gonna put this back over here. We'll set our graduated cylinder aside. So now it says heat the pot of deionized water on the stove. So we got my deionized water, 250 inside of this pot. We're gonna heat it up on the stove. So we're gonna set it to, we'll set it on medium. Yeah, set it on medium, and we're gonna wait for it to begin to boil. So just wait for the deionized water to boil and use your thermometer to measure the temperature and record the boiling point of the water. So we have it. Got the stove turned on. We have our deionized water. We're gonna wait for it to start boiling. Just to preface, I got my safety goggles. I'm wearing some shoes, pants, and a long sleeve t-shirt. I know that's later on in the lab, but I just wanted to preface that before. So there we go. Now we're just waiting. We're gonna wait. Let me get my pencil ready. Oh, my thermometer. I got my thermometer right here. Right now, nothing's happening. That's okay though. We're just gonna keep waiting until it starts to boil. Okay. Let's see, is there anything else we could do? Oh, here. We'll wash out my graduated cylinder of ionized water or deionized water. Let's go in. Still no action from our deionized water. Alright. Get out a paper towel. So help dry this off. It's starting to give off little water vapor. That's always a good sign. And we're about to start boiling soon. Okay. There we go. I cleaned off our graduated cylinder. Okay, we got some bubbles starting to form right now. Okay, looks like it's about to maybe start boiling here in a minute or two. Okay, we're just gonna keep waiting. Okay, I'll show you. That's what it's looking like right now. Got a few bubbles starting to form. Uh-oh. Looking like it's starting to boil. Yep. And just like that, it's starting to boil. We're gonna put our thermometer in. And it's looking like maybe one. Wait. It's hard to tell. It hasn't stopped moving yet. Maybe around 180? Is that 180? Yeah, I'm thinking. It's starting to go down. No. Look like 160. That's what it looks like. So here. Let me get a paper towel. Thing. Okay, let me write that down. Yeah, maybe. Yeah. Let me type that. Water boiled at let me see. So yeah, 180. 180. Okay, so now we're gonna shut off our stove, wait for that to settle. Now we're gonna move on to the next part. Next it says, measure out 25 milliliters using a graduated cylinder and place the water into a beaker. So I got my beaker right here. Grab my graduated cylinder right here. We're gonna do 25 milliliters. Here we go. Pour it out. Antonio, get down. A little more. There we go. We got 25 milliliters of water. We're going to pour this into our beaker. Give 1 second. Alright. Next it says, obtain a package of Kool-Aid and pour the Kool-Aid into the same beaker. So we got our pack of Kool-Aid. I just grabbed a random pack. We got cherry right here. And it wants us to pour it into the same beaker, which is right here. Okay. There we go. So we got Kool-Aid in there. So what it looks like, our powder is starting to kind of form up on the bottom. It's hard to tell. Yeah, it looks like we got powder on the bottom, the bottom layer. And then obviously the water has changed to a different color. So it's about, well, it's obviously turned red. Okay, it wants us to record our observations. So our first observation is, oh, let me close my water and throw away the Kool-Aid package. So yeah. Our first observation is the water is a different color. Second observation is the Kool-Aid powder clumps up at the bottom. Kool-Aid up at bottom. And this would be a physical change. Or it would have physical properties because we're not forming a new substance. It's still powder, it's still Kool-Aid, and it's still water. And it would be a mixture, but right now it's a heterogeneous mixture, not a homogeneous, because you can clearly see the powder still at the bottom. But I'm sure if I were to mix it, it'd be a homogeneous and you couldn't tell the difference. Yeah, let me write that down. Genius mixture. Okay. So next, it wants us to obtain a package of ground beef. So I got a package of ground beef right here. And then it wants us to write down your observations of the ground beef. So let me open it first. There we go. There we go. There's our ground beef. Throw away the plastic. So here we go, ground beef. Let me move this out the way. So some observations I'd say off rip is the color, which is like a pinkish reddish color. Let's say pinkish red color. Let me smell. It smells like raw meat. I'll touch it. It's squishy. Other than that, yeah. See, it's all clumped up together. It's squishy. And yeah, I think that's good for our initial observations. It wants us to place the ground beef in a skillet and cook your ground beef until it is brown. So I have like a pan, I'd say. There's a pan. We don't have a skillet here, but I figured this is the next best thing. It's what my mom uses to usually cook stuff like that. So let me get some spray real quick, make sure it doesn't stick. Okay. So we're going to place this ground beef inside of our pan. Point it that way. Okay. And we're gonna put this baby on. There you go. There we go. So right now we have it in our pan, just like this. I have the stove turned on. We're going to cook it until it turns brown. Basically fully cook it. We got a spatula to help me with the ground beef. Make sure it's all good. Here we go. And then, yeah. I'm taking a package of ground beef. Okay, and then it wants us to record our observations of the ground beef after it is cooked. And we're going to determine whether it's a physical or chemical change. So we're going to cook it, and then we're going to look at it, and we'll determine whether it's a physical or a chemical change. Initially, though, I'd say it's a chemical change, because more often than not, with chemical changes, a chemical changes happens whenever you take a substance and it turns into something completely new, or new matter, or new substance. And usually the thing is with chemical changes, more often than not, they can't be reverted back. Some can. I mean, I don't know all of them off the top of my head, but I'd say 90%, 90% of them, usually they can't be reverted back to their original state. And whenever we cook this ground beef and it becomes brown, we can't make it raw again or turn it back to pink or back to being squishy or smelly, or smell like raw meat. So I would say it would be a chemical change, just off initial guessing. I don't know if we could maybe change the angle here a little bit so y'all can see me kind of mix it up just a little bit. Here we go. Let's make sure we get. Okay, we have it on. Have it on high to help it cook just a little bit faster. Say observations right now, I'd say really nothing's changed. It pretty much looks the same still for right now. I did kind of mince it just a little bit to help make it go faster, so it's not one big clump of ground beef. Okay, so here we go. Let me put away my thermometer while we're waiting right here. Let me clean it off. Because I don't think we need a thermometer again. Let me just double check though. Oh, no thermometer. Okay. We're just still kind of waiting here. Okay. Maybe we'll. Okay. We'll set this back over here. Still waiting on it for it to cook. We got a little brown right now, just in the bottom half. Mince it up some more. Yeah, I'll show y'all. So we got a little bit of brown. That's to show it's starting to get a little cooked. It hasn't fully cooked yet, so we're gonna still kind of mince it around, let it sit. Here, I'll put you guys back over here. Okay. A lot more brown is starting to happen. There we go. Yep. While that's still starting to cook, with our other two experiments we did, or things that we did here in our lab, I'd say this, with the deionized water, I'd say that's a physical change because we're just boiling it. Nothing's like changing really about it. So basically no new substance was formed. We were able to measure it and observe it without changing its identity at all. Okay, our ground beef is starting to come along. Let me show y'all. You guys can kind of see it's not really that pinkish color anymore. It's starting to become brown. We'll set you guys back right here. Okay. So maybe just a little bit longer, and it's looking good right now. And we should be good to observe. I mean, we can already observe it right now. Put this down, get my pencil and paper ready. Oh, got my paper all wet. That's fine. We'll let that kind of dry. Okay, almost fully cooked. I can still see like little hints and traces of pink. Not too much though. Okay. Maybe we'll take a few more minutes. Okay. Okay, it's starting to smell a little good. That's good. So we can already tell that our initial observations are already changing. Its color has changed. It's no longer pink, reddish or pinkish redded. It's what's it called? The smell has changed. It doesn't smell like raw meat anymore. And obviously I'm not gonna feel it, but I'm assuming it's probably not as squishy as the raw meat was. Or some of the things I said. Sticky. It's not gonna be sticky. And lastly, packed together. It's not all packed together anymore because now that we, dispersed it out and now we're cooking it. Okay, I'm thinking that it's about done, I'd say. I'll show you guys what it's looking like. Yeah, it already smells way better than the raw version of it. Let's say, yeah. Any more? Nope. Let's turn off our stove. Let's set it on a different one. Okay. These away. Okay, so going to record our observations now. So our first observation is it's brown. Yep. It's brown. I'd say maybe kind of smells like a hamburger. I'd say it kind of smells like a hamburger, or basically cooked meat, if that makes sense. It's not packed together anymore. It's not packed together. It's not as squishy. We can tell by me using my spatula. Not squishy. Okay. And it says it wants us to determine whether this is a chemical change or physical change as predicted. This was a chemical change. because, like I said, hold on 1 second. Because we can no longer revert it back to being raw meat again. And, you know, we took the raw meat and we created cooked meat. Sure, two things. Okay, now that that's done, it wants us to attain a bottle of vinegar. We got vinegar right here. Here, let me clean off my station or my counter. Move these over here. Okay. Oh, I'm blocking the way. Here, I'll put this back over here. So you got our vinegar. It wants us to measure out 10 milliliters of vinegar into a beaker. We got our other beaker here. We're gonna measure 10 milliliters by using our, there we go. Ooh, that smells crazy. So we got 10 milliliters, and we're gonna pour that into our beaker. The reason I use my graduated cylinder is it only goes by 50s on here, so I wouldn't be able to tell about 10 milliliters, or I would just rough balling it, but I want to be precise. So then next, it says obtain a box of baking soda. I got a bag of baking soda, same thing. And then it wants us to place enough baking soda in the beaker to cover the bottom of the beaker and record our observation. So first we are gonna get one of these. Help me kind of do it so I'm not pouring a big glop at once. Okay, so it starts to fizz up or produce bubbles. That's it, that covers up the bottom. Yep. Maybe just a little bit more. We'll set this there. So our observations was that it started to fizz up or bubble up. So started to fizz up slash bubble up. And we already know that an example of a chemical change is when it's bubbles up, kind of, or bubbling. And as we know, since it just did that, it would be a chemical change. Whoops, graduated cylinder. So, yep, there we go. That was our part of the thing. Yep, and you can see all of the bubbles at the bottom. Okay, let me pour this out. We can also pour out my, or do we need another beaker? Yep, we need one more beaker. Here, I'll pour out the Kool-Aid mixture. Okay, let me clean out the inside of it. go. We got our beaker, nice and clean. So next it wants us to pour the contents down the drain and wash it out with the beaker. We'll also wash out this one too. I'm gonna dry this one as well. So we have 2 beakers just in case we're gonna do another one. Okay. So 2 beakers. It says obtain a bottle of Drano. Please wear gloves, goggles, long shirt, pants, shoes that fully cover the feet for this part of the experiment. Make sure you're very careful. We got goggles, shirt or long shirt, pants, shoes. I got my gloves right here, so we'll pop these bad boys on. You make sure that you know they're on. So there we go. Our gloves, 2. So next it says obtain a bottle of Drano. We got a bottle of Drano, and then it wants us to pour 20 milliliters of Drano into a beaker. So we got our funnel to kind of help us do this. Okay, 20 milliliters. We use our little funnel. Maybe we should use the big funnel, I'm not sure. The big funnel is too big. Okay, that's funny. So we'll use our little funnel. There we go. We want to be, it says be very careful. So like I said, we got everything we need. So we're going to pour 20 milliliters inside of here. Okay, maybe just a tad bit more. There we go. So we have 20 milliliters of Drano inside of here. Let me wash out my funnel. We'll finish cleaning that later. And then record our observations. So initial observations is the liquid is clear, you know, nothing too much. Maybe it's a little, it's pretty movable, pretty free moving, not so thick. So let's say it's clear. Not too thick. Do a smell. It smells like kind of like a cleaning. Yeah, kind of like a cleaning product. That's what it kind of smells like. Smells like a cleaning product. Okay. So it wants us to obtain Epsom salt. Epsom salt right here. See? Epsom salt. It wants us to fill the bottom of the beaker with Epsom salt. So again, this time we'll use a different one. Kind of help me make sure I get all to the bottom. So here we go. happening? So first I'd say the liquid kind of got brighter, more white, not as clear. Most of the salt, you know, went directly to the bottom. You know what I'm saying? We got like this kind of like white looking substance kind of on the top, kind of like a top layer. I'm not 100% sure. So we'll close our Epsom salt. We'll close our bottle of Drano. Move these back over here. Okay, yeah, I'd say that's pretty much my observation. Let me write that down. So we got, it's white, salt to the bottom, salting to the bottom. We'll see, we'll smell. Oh, has a different smell to it now. Just a little bit. You can still kind of smell like the cleaning, but you can also smell, it kind of smells like a little salty. I don't know if that's a thing, but it kind of does smell a little salty. So we'll say, okay. Here, well, oh, do I need this still? Here, we'll close this out, or pour down the drain. Okay, do I need my beaker again? Nope. Okay, for the next part, taking off my gloves now. Here, I'll set these here. It wants us to get a sparkler, and wants us to light the sparkler and record our observation. So I got my sparklers here. And stuck it up. So we're gonna grab our sparkler. We got a sparkler right here. We're going to get a lighter. And here, I'll go outside. It wants me to go outside, so let's take a trip to the downstairs bit. Okay, I'll set you up right here. Okay, got our lighter, got our sparkler. It's very windy, so might be a little hard for it to get lit. There we go. We got our spark. Oh. So if we look, we can see as the fire kind of goes down, we'll see little sparks fly left and right. Ooh. Like I said, it's very windy, so might be a little hard for it to catch on fire. There we go. Record our last little bit. So we got sparkler. Almost done. About to reach the bottom. There we go. Just like that, the sparkler's done. Alright. There we go. So throw that away there in the trash. Okay. Head back inside. Now we're gonna record our observations here. So first I'd say obviously it's a chemical change. Second, I'd say sparks flew around, and then I'd say the end began to shrivel. Kind of like, you know, after the sparkler goes down, the end will kind of shrivel up and get like all kind of tight, and most of the time it'll fall off, but which in my case it did fall off. So next, it wants us to obtain a box of laundry detergent. It should be powdered. So we got our, let me put this away. Our laundry detergent. That's fine. Does it break off? Oh, it's supposed to. Okay, I thought I broke it. So we got our thing of powdered laundry detergent right here. Let me kind of clear off my counter just a little bit. This goes right here. And we'll wash that too. Okay, it wants me to place some laundry detergent in my hand. Okay, maybe we should do this over my trash can. Oh, it wants me to pour water on it. I will do it over my sink actually. We'll set these on this. Okay. I'll place you right. Is it wet? Oh, it might be a little wet. There we go. So we're gonna take our laundry detergent right here, and then slowly pour some water over the laundry detergent in your hand and record your observation. So we got our water bottle right here. We got our laundry detergent. I will put in my right hand, so we'll take some. How much does it want me to place? I don't think it said actually. So look, we got our laundry detergent in my hand. Slowly pour some water over the laundry detergent in your hand and record your observation. So we got laundry detergent right here, water bottle right here. We're gonna pour. kind of begins to fizz up. My hand's getting warmer, believe it or not. And we'll do the rest of it. So, dry off my hand. We'll close the lid to this. Spoon it. There we go. So I'd say our observations were that it fizzed up. It fizzed up a little. My hand became warm. And I'd say the powder basically kind of dissolved. Yeah, basically dissolved to where there wasn't as much powder in my hand anymore as I was pouring it down. So those are my observations. And it wants us to place your data in the data sheet, which we'll do. And then I don't know if I'm supposed to do this here or in the data sheet, but it says find one element, compound and mixture. So for my, here, I'll just do this. We got our element, we got aluminum foil, which would be aluminum, which is a metal, not a metalloid. We got our, my compound. My compound, I did water, because it's H2O, which 2 hydrogen atoms and 1 oxygen atom, which is a compound. For my mixture, we got lemonade, which is a mixture of like lemons and water and like sugar. Lemonade. Okay. And there you go. That's my lab.